Hey, geometry kids. I hope you're doing well. This is your first video lesson, and I'm excited to see how this goes, seeing how it's going for you, and talking with you soon, and just get some feedback from you and touching base with you again. A couple things before we get started is, first of all, on the shared drive that I gave you, make sure in geometry you're familiar with everything that's in here. One thing new is all the student journal answers are in here as well for chapters 9, 10, and 11. So if there's anything I don't get to, maybe some of the tail end stuff I don't get to, if you want to check your answers, you can come in here and check your answers. So there's also some geometry formulas. We'll get into that quite a bit. Here's your link for math lessons and the resources for that. This is where I'll be putting the links. If you go to algebra, I have a couple of them in there already, but those go to the links to the videos. That's how you can access the videos for each of these lessons, other than just through the YouTube channel that I have too. So the other thing I wanted to talk about is just that if you have a specific question that you want to get answered, it's just kind of you want to get it done so you can move on. The best way to do that without going into a lot of detail on my end is just take a picture of the question and the work you've done. So if you've tried it and you don't know where you went wrong, so if you have a question like that, where did I go wrong with this, shoot me a text, send me an email of those images, including that, and I will respond and say, hey, you need to check this part, or you didn't do this part right, but I need to know the question, either just a question number or whatever, and what work you have done with it. If it's just a general, I don't know what to do, I'm not sure how to get started with that, we need to wait until some one-on-one communication to our video times, and we'll take it from there. I'm going to try to keep these videos under 15 minutes. I've kept them under 20 so far, the ones that I've done, but we'll see how they go. Some of this introductory stuff on this first one may take us a little bit longer, but let's get that part off. You don't need to stare at that the whole time. Okay, so 9.4. We are in the middle of chapter 9. Remember, we're working with right triangles. We had a lot of review with the similarity and proportional parts prior to spring break, 3 lessons that we did before, and now we're getting into some trigonometry, which I think is kind of fun and exciting. So there's 3 ratios that are important on right triangles. That's the tangent, the sine, and the cosine. And this first lesson is with the tangent. And the main question what we're doing is we have to have a right triangle. That means we have to have a right angle right here. Okay? The tangent is actually a ratio. So tangent is a ratio, which means it's 2 things being divided by each other. And a lot of times you'll hear this say that tangent is the opposite side of an angle over the adjacent. So if this is my angle right here, they're talking about angle A. So this is my angle. I'm going to use a fancy symbol called theta. That's a Greek letter. And if those who take trig and advanced math, you'll see that a lot next year. This is your opposite side. So on the right triangle, this is opposite. This is adjacent. Adjacent means you are next to it. So, and this is a hypotenuse. We're not using the hypotenuse for this ratio. We will use the hypotenuse for sine and cosine. So the hypotenuse is the longest side. Across the triangle is the opposite side, and the leg that makes the angle is the adjacent side. So tangent uses the 2 legs. We say tangent equals the opposite over the adjacent. That's some of the shortcuts there. Tangent is opposite over adjacent. The word we'll use later is TOA. Tangent is TOA. Tangent is opposite over adjacent. So, how this works, this is more detail on page 259. So tangent is, there's the opposite over adjacent. Okay, so if this is angle A, this is the leg that's opposite, this is the leg that's adjacent. The terminology here, angle of elevation, that comes into play in some work problems, that would be this. That is the angle of elevation. Now, as you go through the student journal, I highly encourage you, when you come to definitions, come back and write them down. You'll remember them a lot better, okay? You'll know how to use them a little bit better if you take the time to actually write them down. Okay, so the angle of elevation is right here, and imagine this is you, and you're looking up at a bird. Caw-caw, there's a bird up there. Okay, If this is the horizon, this right here would be your angle of elevation. So how much did you look up? Or if you're building a ramp, how much does it go up? The angle that it goes up, that's your angle of elevation, how much things are going up. Okay, so tangent is opposite over adjacent. Opposite over adjacent. So find the tangents of the acute angles. So there's going to be two answers. Write each answer as a fraction and as a decimal rounded to 4 decimal places. So here we have angle R and we have angle S. Those are the two acute angles. So if I'm up here, if I want the tangent of angle R, remember we're not using the hypotenuse. So this is my hypotenuse. I might as well just cross that off. I do not need the hypotenuse. Okay, so the tangent of R is the opposite side over the adjacent side. The tangent of R is the opposite side over the adjacent side, and that's what your answer would be. So they want in lowest terms, so 45 divided by 24. Of course, we can reduce that. 15/8. And as a decimal to 4 decimal places, so that's 1.875. Okay, so the tangent of R is 45 over 24. It's that ratio. Whatever angle it is, the sides will always have that ratio. That's what's cool about the trig here, is for every triangle that has this angle, we don't know what it is, but it'll always have a 1.875 ratio between the two legs. So the tangent of S, that's the other acute angle down here. There's S. This one, the opposite side is 24. The adjacent side is 45. So 24 over 45. That'd be 8 over 15. Which is 0.5333. Okay, so try this. Pause the video, go back and watch it again, and then move on and try some of these on your own. Don't just wait and watch me and say, okay, I know what you're doing, I know what you're doing. You need to be writing this down. You need to be recording this. You need to be trying some of this beforehand, and then come back and watch and see if you did it right. Okay? You need to learn the material, not just get by and get it done. So try the next one. We have J and L. So the tangent of J would be opposite, which is 7 over 5. Okay, that's 1 2/5. That'd be 1.4. Tangent, the other one is L. Tangent of L would be opposite, which is 5 over 7. Notice those are reciprocals. Okay, and 5 divided by 7 is 0.7143 to the 4th decimal place. Okay, A and C are our two acute angles. So tangent of A is opposite, 2 over root 2. You may want to rationalize the denominator, so take top and bottom times the square root of 2, and you get 2 root 2, 2 times root 2, over the square root of 4, which is 2, reduces just the square root of 2. The tangent of A would be the root 2, and that is 1.4142. Sorry, there you go. 1.4142. So this can probably be left as root 2 over 2, or 2 over root 2. And I don't know if you really actually have any that square roots show up with it now, but that'd be the tangent of A. Tangent of C would be root 2 over 2. You can leave it like that. And that is approximately 0.7071. Okay, so that's just writing the tangents and getting those recorded. Now you get to solve for a triangle. Now before, when we had a right triangle, we had to use Pythagorean theorem, a squared plus b squared equals c squared. Trigonometry and these ratios are kind of fun because now you get to have an angle and a side. If you have an angle and a side, you can figure out all the other sides. Okay, because every triangle has a 90-degree angle and a 10-degree angle. They're going to be similar to each other because you have angle-angle similarity. That means every ratio of the side is going to be the same no matter what size of triangle you have. So we want to set up the tangent equation. So here's my angle. I'm going to say the tangent of 10, the tangent of 10, your tangent of a degree angle, is the opposite side, so what's opposite, over the adjacent side, which is x. So the tangent of 10 is a number, and you can look up a table of trigonometric values and you can find out what that number is. Back before calculators, that's what they did. But you have a handy-dandy calculator, hopefully. You need one, or else use the one on the computer. And if the x you need is on the bottom, these can kind of switch places. So x equals 5 divided by the tangent of 10. Don't just switch the 5 and the 10. The tangent of 10 is the value. So you go 5 divided by tangent of 10. And I get about 28 point to the nearest 10th, 28.4. So that would be the length down along here, 28.4. So if that's 5 feet, that'd be 28.4 feet. Allows you to find that. If you did not get 28.4 when you type this in, your calculator may be in a different mode called radians, and you just need to get a hold of me and send me a picture of your calculator. I'll try to help you figure it out. Or just type in Google your brand and your model number and say converting, changing to degree mode. Change to degree mode. Okay? Okay, so in this one, here's our 64. So I'm going to say tangent of 64 equals opposite, now the x is opposite this time, over the adjacent, which is 13. So tangent of 64 equals x over 13. This one, just multiply the 13 over, so x equals 13 times the tangent of 64. 13 times the tangent of 64. So x is approximately, to the nearest 10th, 26.7. So stop, try the next one, then come back and I'll have the answer for you. Okay, so tangent of 31 should equal the opposite over adjacent. So tangent 31 is 24 over x. So x equals, x is on the bottom, so 24 divided by the tangent of 31. And x is approximately 39.9. Okay, in triangle CDE, angle E is 90 degrees. So draw it, label it, angle E, and CDE. We'll go like that. And the tangent of C is 4 over 3. Find the tangent of D. Write your answer as a fraction. So a couple different ways. First of all, C and D are the two acute angles. Okay, so if this is the tangent of C, remember this is the opposite side, this is the adjacent side. So C, the opposite, would be 4, the adjacent side would be 3. So if you're looking for the tangent of D, you take the opposite side, which is now 3, so the tangent of D would be 3 over 4. Opposite over adjacent. So those are reciprocals of each other, much like what we found up here. These were always reciprocals of each other, the two acute angles. The tangents were reciprocals of each other. Okay, a few word problems. Going over my limit, but we'll do it. If you know what you're doing, you can move on. So, environmentalist wants to measure the width of a river to monitor its erosion. From point A, she walks 100 feet downstream, measures the angle from this point to point C, which is straight across the river, to be 40 degrees. So that's 40 degrees. How wide is the river? Round to the nearest 10th. So we want that length right there. So they walk down 100 feet, they measure that angle. Now we can figure out how wide the river is. I'm going to start the tangent of 40 equals opposite. So what's opposite? Over adjacent. The x is on top, so x is 100 times the tangent of 40. And you should get 83.9. So about 84 feet. Is it feet? Yep. About 84 feet across. So 1 year later, she returns, measures from the same point, she walks downstream, and now we have a 51-degree angle. So we have 100, we have 51, we want to know x. So let's follow the same formula. X would equal 100 times the tangent of 51. If it's a bigger angle, is it going to be more or less? Can you have less erosion? I guess it could build up. Oops. There we go. So now x is approximately 123.5 feet. So yes, it went on. Here's that term, angle of elevation. Boy flies a kite at an angle elevation of 18 degrees. So if this is the boy down here, hello, that means this is 18 degrees, angle of elevation up. The kite reaches its maximum height 300 feet away from the boy. We're going to put that here. What's the maximum height? Around to the nearest tenth. So again, opposite over adjacent. Tangent of 18 equals opposite over adjacent. So x is 300 times the tangent of 18. And we get 97.5 feet. So that's a pretty low angle for a kite, it seems like. Find the perimeter of the figure. This one, check your answer if you contacted it. If you want help, I can walk you through it. This one takes a little bit of time to get through, so I'm not going to take the time on the video to do that. So that takes care of that. We're going to move into sine and cosine ratios next. Those are just a different one, and we get to talk about SOHCAHTOA, and we'll go with that. So let me know if you have any immediate questions, or I will see you on Wednesday for our class discussion. So good luck, and thinking of you, stay Bluebird strong.